The 3-digit number is chosen at random. What is the probability that it is divisible by neither 3 nor 4? 3-digit numbers, there are totally 900 of them. How many of these are multiples of 3? 900 consecutive integers. How many of these will be multiples of 3? 300 of them. I'm talking about the numbers from 102 onwards. 102, 105, 108, 111, 114, all of that. All the way till 999. You can count it, brute force it and say, hey, 102, 105, 108, 111, all the way till 999. But we know 900 is a multiple of 3. Any 900 consecutive integers, there will be 300 multiples of 3. How many multiples of 4 are there? 900 by 4, 225. What is the probability divisible by neither 3 nor by 4? We have to remove these numbers. But we are removing these numbers. There will be numbers that are multiples of 12. Which is 900 by 12, 75 numbers that are there in both of these lists. Numbers like 108, 120, 132, 144, 156, all of them that are there in this list and in this list. Double counting them. To subtract that. 300 plus 225 minus 75. That is 225 minus 75 is 150, 450. So 450 numbers out of 900 are multiples of 3 or 4. How many are divisible by neither 3 nor 4? The remaining 450, what is the probability? 1 by 2. Half the numbers satisfy our condition. A goldsmith bought a large solid golden bar at INR 1 million, 10 lakhs. You put INR, I think you should put 10 lakh. They put 1 million. Melted it to make a certain number of solid spherical beads such that the radius of each bead was 1/5 of the radius of the original ball. Ball. Radius R, small radius R is equal to 5R. Okay. Straight away, what do we know? This is 4 by 3 pi R cube. That is 4 by 3 pi R, small r cube. This is 1/5 R. This is, if I put, there will be 125 of these small balls that we can create from the big one. 5 into 5 into 5. Right? So this volume, there are n balls, assume n into 4 by 3 pi r cube equals 4 by 3 pi capital R cube. This is 5 times small r. 4 by 3 pi, 4 by 3 pi will go away. 5 into 5 into 5 is 125. So with that big giant ball, we are creating 125 small spherical balls. Brilliant. Assume the cost of making golden beads is negligible. So it's just the cost of the golden ball. Making it into small things is negligible. If the goldsmith sold all the beads at 20% discount on the listed price and made a total profit of 20%, and the listed price of each golden bead was. So cost price, selling price, listed price. This were X, this is 1.2X. I offer something at a 20% discount and sell it at 1.2X. Why is it at 1.2X? You make a 20% profit. So if cost price is X, selling price is 1.2X. Now what about listed price or marked price? You have a listed price on which you offer a 20% discount and arrive at a selling price. So 0.8 times listed price is 1.2X, or listed price or marked price is 1.2X by 0.8, which is 1.5X. 12 by 8, which is 1.5X. So listed price is 1.5X. Lovely. Now cost, we want to find the listed price of each golden ball, each golden bead, the small one. How many of those are there? 125 are there. What is the cost price of each of those? The big cost price divided by 125. Why? We are making 125 small beads. So what is the answer we are looking for? 1 million divided by 125 into 1.5. 1 million is the total cost price. 1 million by 125 is cost price of each golden bead. That into 1.5 is the listed price of each golden bead, which is what we need to find. 1000 by 125 is 8. So 1000 into 8. 8000 into 1.5. How do I know 125 into 8 is 1000? I know 1 by 8 is 0.125. Let a, b, c be real numbers greater than 1 and n be a positive real number not equal to 1. Log a to the base 2. So log to the base n of log a to the base 2 is 1. It means log a to the base 2 is n power 1 is this number, or a is 2 power n. Log to the base n of log b to the base 2 is 2, or log b to the base 2 is n square, or b is equal to 2 power n square. Remember, this is 2 power n square, not 2 power n the whole square. 2 power n the whole square is 2 power 2n. That's not what this is. Log b to the base 2 is n square. b is 2 power n square, not 2 power n whole square. That will become 2 power 2n. That's not what this is. Right. Log to the base n of log c to the base 2 is 3, or log c to the base 2 is n cube. C is 2 power n cube. Brilliant. So a is 2 power n, b is 2 power n square, c is 2 power n cube. We need to see which of these choices will work. A power n plus b power n equal to c power n, not a chance. A power n is 2 power n whole power n, 2 power n square. B power n is 2 power n square whole power n, 2 power n cube. 2 power n power 4. Doesn't work. A plus b, a power n plus b whole power n is AC. Let's check this out. A power n is 2 power n whole power n plus 2 power n square whole power n is 2 power n into 2 power n cube. Maybe this can work. Let's check this out. This is 2 power n square. 2 power n square plus 2 power n square whole power n is 2 power n cube. This is 2 power n square plus 1 whole power n. 2 power n square plus 2 power n square is 2 times 2 power n square. That is 2 power n square into 2. That is 2 power n square plus 1. This is 2 power n plus n cube. It's 2 power n cube plus n equal to 2 power n cube plus n. Brilliant. This works. I'm going to verify the other two. A plus b equal to c. 2 power n plus 2 power n square equal to 2 power n cube. Not happening. B minus a whole power n is c minus b. This won't work because there's a 2 power n square minus 2 power n whole power n is 2 power n cube minus 2 power n square. This could work. B minus a whole power n. This is 2 power n cube minus 2 power n square. It's 2 power n cube minus 2 power n square. I thought this will not work, but it looks like this also work. Which of the following is true? This is true and this is true. 2 power n square minus 2 power n the whole square, whole power n. Okay, this doesn't work. I've just expanded it like this. It doesn't work like that. X square minus y square whole cube is not x power 6 minus y power 6. So don't make these silly mistakes as if you don't know anything. This is just wrong. 2 power n square minus 2 power n whole power n is not 2 power n cube minus 2 power n square. It doesn't work like that. This side is fine. This side, x square minus y square whole cube is not x power 6 minus y power 6, which is why I walked into that. Fine. So this is wrong. This is right. A, C and D are wrong. B is correct. Absolutely delightful question. To crack the log part, then come to the simplifying part, then look at the choices and go methodically. Beautiful question. The harmonic means of the roots of the equation, 5 plus root 2 x square minus bx plus 8 plus 2 root 5 equal to 0 is 4. Right? The roots of the equation were alpha and beta. Harmonic mean is 2 alpha beta by alpha plus beta. Alpha plus beta is minus b by a. This time will be b by 5 plus root 2. Alpha beta is c by a, 8 plus 2 root 5 by 5 plus root 2. So harmonic mean, the roots are alpha and beta. Harmonic mean is 2 alpha beta by alpha plus beta, or which is 2 times 8 plus 2 root 5 by 5 plus root 2 by b by 5 plus root 2. The 5 plus root 2 gets cancelled. This is given to be 4. 2 into 8 plus 2 root 5 by b is equal to 4. 1, 2 gets cancelled here. Another 2 can get cancelled here. 4 plus root 5. 4 plus root 5 by b is equal to 1. b is equal to 4 plus root 5. We know roots are alpha and beta. We know alpha plus beta, alpha beta minus b by a plus c by a. Harmonic means 2 alpha beta by alpha plus beta. Plug it in, simplify, we've got freebie. Consider an 8 cross 8 chessboard. The number of ways 8 rooks can be placed on the board such that no 2 rooks are in the same row, no 2 are in the same column. Brilliant, brilliant question. Super challenging. It's called a rook polynomial. And we'll do it by the simplest, juiciest method, taking for granted that this is one of those things that you know. Otherwise, it's very difficult to figure out in the exam hall. I'm going to go brick by brick and say, hey, let's place one rook in this row. Right, so I'm going to go row by row. Let's place one rook in this row, row 1. There are 1, 2, 3, 4, 5, 6, 7, 8 options for us to place the rook. Hypothetically, let's say the rook is placed here. I'm placing a cylindrical thing, not a rook exactly. And you move to row 2. Very simple funda. You move to row 2, R2. No 2 rooks can be placed in the same row. So for this row, there's only one rook. For this row, I have to place one rook. The question says 8 cross 8 chessboard. The number of ways 8 rooks can be placed on the board such that no 2 rooks are in the same row and no 2 rooks are in the same column. Look at R2. This is out. I cannot place a rook here. But 1, 2, 3, 4, 5, 6, 7 options are available. Hypothetically, let me say I'm putting the rook here. Then move to R3. This is out. This is out. 6 options are there. Let me say I'm putting it here. Go to R4. This is out. This is out. This is out. 5 options here. 4, 3, 2, 1. The last rook is going to have only one free column, one free row. Put that in. We are through. How many combinations are possible? 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Just 8 factorial. A set of all real values of x satisfying the inequality x square into x plus 1 by x minus 1 into 2x plus 1 whole cube. A nice question, because one starting simplification is very important. X square into x plus 1 by x minus 1 into 2x plus 1 whole cube is greater than 0. You look at numerator, you look at denominator, you look at turning points, and then you crack it. First of all, x square is always non-negative, and so x square cannot be negative. So I can remove x square from this expression. All I need to keep in mind is I cannot put x equal to 0 as part of the solution. If x is 0, this goes to 0, it has to be greater than 0. 0 is not part of the solution, I can remove x square. Likewise, 2x plus 1 whole square is always positive, greater than or equal to 0. So I can imagine this as x square by 2x plus 1 whole square into x plus 1 by x minus 1 into 2x plus 1 greater than 0. This part is greater than or equal to 0. So remove this completely, bearing in mind that x cannot be 0, x cannot be minus half. That this goes to 0 or this goes to 0, Not to worry about it. If the numerator goes to 0, the expression will go to 0. Denominator goes to 0, that's not allowed. And so this is now x plus 1 by x minus 1 into 2 times x plus half greater than 0. Roots are ideas where something goes to 0. Numerator will go to 0 when x is minus 1. Denominator will go to 0 when x is 1 or minus half. What do? Draw the number line. Put minus half here, minus 1 here, 0 because I need to remember 0, and 1 here. I want to know when this is greater than 0. When x is greater than 1, positive, positive, positive. So this will work. And when x is between minus half and 1, and these three are the roots. 0 I've just added, the roots are here, the turning points will be here. When x is between minus half and 1, so x is say 0, this will be positive, x minus 1 will be negative, x plus half will be positive. Positive by negative, that is negative. So in this region, it does not work because it is negative. In this region, minus 1 to minus half, it will work. Why will it work? So let's say x is minus half plus 1 is positive, minus half minus 1 is negative. Sorry, x is in between here. These two will be negative, this will be positive. Positive by positive, it will work. So in this range, it will work. In this range, all three terms are negative, it won't work. Does not work, works. Does not work, works. So x has to lie between minus 1 and minus half, both not included, or greater than 1 to infinity. X should not be 0. Anyway, x equal to 0 is not part of our solution. We're safe, we're happy. X cannot be minus half, that's also not part of the solution. We're looking for minus 1 to minus half union 1 to infinity. This is our answer. Carve out the squares, keep them aside, worry about numerator and denominator going to 0 because it's a greater than, not greater than, not equal to. Keep that in mind, you have to worry about that. Then find the roots. Roots are places where numerator goes to 0 or denominator goes to 0. Mark down the roots. Roots will be turning points. Go point by point, range by range, get through. The difference between compound interest and simple interest for a certain amount of money invested for 3 years at an annual interest rate of 10% is 527. Then the amount invested in INR is very simple question. Amount invested, let it be P. Then compound interest is P into 1.1 whole cube minus P. Amount is P into 1 plus R by 100 whole power n. Rate of interest is 10%. So R by 100 is 0.1 for 3 years whole cube minus P, that will be the interest. From amount, subtract principal. What is simple interest? 10% into 3 into P. So this is P into 1.331 minus P. This is 0.3P. 0.331P. This is 0.3P. Which is nice if you think about it, because we know already that compound interest should be more than simple interest. This is higher than that. The difference is 0.527. 0.331P minus 0.3P is 0.031P is 527. I'm already having this wonderful vibe that 527 will be a multiple of 31. So 31 by 1000 times P is 527. 527 divided by 31, it goes 1 time, 31, 217, 7 times, brilliant, 17, or P is 17 into 1000, 17,000. Hopefully that there in our choices it is, we're very happy. In a group of 120 students, 80 students are from the science stream and the rest are from the commerce stream. Whenever I'm given questions like this, my first thought process is, are we looking at discrete sets or overlapping sets? Sometimes the question will say there are 120 students, 70 like physics and 80 like mathematics. Automatically says some are there that like mathematics and physics. There could be a few who like neither. In this case, it is not like that. 80 are from science rest are from commerce. So from 120, 80, 40, science, commerce, non-overlapping exhaustive sets. There's nobody who likes science and commerce, who's from the science stream and commerce stream, nobody who's in neither. Life is simple. It is known that 70 students support Mumbai Indians in the Indian Premier League. All other students support Chennai Super Kings. Again, all other students. 120 here. 70 is Mumbai Indians. 50 is CSK. The number of science students who were supporters of Mumbai Indians is, can't find the answer, but which is why the choices are in terms of ranges. Right? So what I'm going to do, I'm going to classify this, because there are going to be science and Mumbai Indians, commerce and Mumbai Indians, commerce and CSK, science and CSK, all kinds of stuff. So what I'm going to do, I'm going to say, hey, let me box this out like this. Let's say this is MI, this is CSK, total of 70, total of 50. This is science, this is commerce, total of 80, total of 40. Nice. We want to find 70, the number of science students who are supporters of Mumbai Indians. We want to find this number or the range for this number. Right? What is the maximum this can be? Can this be 80? It cannot be 80, only 70 support Mumbai Indians. Can this be 70? Yes, it can be 70. Put this as 70, put this as 10, put this as 0, put this as 40. We're good. It's possible. So it can be 70. That's the maximum it can take. It's very nice. So this can be 70. That is possible. It can go up to 70. When will it be 70? When I say, hey, put this as 70, put this as 10. This goes to 0. This goes to 40. 70 plus 10, 80 plus 40, 120. These two add up to 50. These two add up to 70, 80, 40. Works. It can be 70. That's the maximum it can go, 70. All Mumbai Indians fans sit inside science. Okay? But that's not there in our choices. Nobody's talking about maximum. It's exactly between 15 and 25, between 20 and 25 are wrong. Exactly 20 is also not the case. We've got 70. So I'm already guessing this should be the answer. Hey, but let's see if we can arrive at that. What is the minimum it can go to? The smallest this value can take. If this has to be small, this has to be very high, this has to be very high. The maximum this can be is 40, maximum this can be is 50, this number. So you can put this as high as 50, put this as high as 40. This is 50, this can go to 30, this is 40, this can go to 30. It has to be minimum 30. If it is 25, that be 55 here, that's not possible. Only 50 people like CSK. So this number, science and Mumbai Indians, should be greater than 30 and less than 70. 30 or more, that's the right answer. Others don't fit. The minimum number of times a fair coin must be tossed so that the probability of getting at least one head exceeds 0.8. Probability of at least one head is more than 0.8. What is at least one head? Could be one head, two heads, three heads. All of these up to n heads. The answer is n. So if there are n times you are tossing, number of tosses is n. You can get one head, two heads, three heads, four heads, five heads till n. That adds up to more than 0.8. Or probability of getting 0 heads. 0 heads is less than or equal to 0.2. Not less than or equal to, only less than. What is probability of 0 heads? Probability of all tails less than 0.2. Now it is very simple. Probability of getting, if you're tossing it once, probability of getting a tail is 1 by 2. Probability it twice, probability of getting both tails is 1 by 2 into 1 by 2. 3 times 1 by 2 into 1 by 2 into 1 by 2. So 1 by 2 power n is less than 0.2. What is the smallest n that satisfies this? You're through. 1 by 2 square is 0.25. 1 by 2 cube is 0.125. You got it. 3. You toss a coin 3 times, there is more than 80% chance of getting at least one head. There's only a 12.5% chance of all these throws being tails. Polynomial p of x leaves a remainder 2 when divided by x minus 1 and a remainder 1 when divided by x minus 2. Fine. The remainder when p of x is divided by x minus 1 into x minus 2. It's a beautiful question. Fine. So we know that p of x divided by x minus a, the remainder is p of a. From this we know p of 1 is 2 and p of 2 is 1. Nice, brilliant. P of 1 is equal to 2, p of 2 is equal to 1. But how do we find out what is the remainder when p of x is divided by x minus 1 into x minus 2? That is very tricky. What do? We reframe this. P of x by x minus 1, remainder is 2. This means p of x is x minus 1 times some q of x plus 2. We have p of x divided by x minus 1. You keep dividing, write down all the things, and then finally you get remainder 2. Here there is a q of x. Any number is a divisor into quotient plus remainder. That means p of x is x minus 1 to q of x plus 2. Likewise, p of x is x minus 2 into r of x plus 1. Brilliant. So I'm going to rewrite this. P of x is q of x into x minus 1 plus 2. P of x is not q of x, some r of x into x minus 2 plus 1. Now we need to have x minus 1 into x minus 2. What do we want to do? We want to write p of x as some f of x, not f of x. F of x seems like it's a function. P r t of x into x minus 1 into x minus 2 plus some remainder p q r s t u v, v of probably v of x. V of x is a remainder. Remainder need not be just a number. It could be itself a function of x. We want to find what this v of x is. How do we do this? We do this in a brilliant method. We call this equation 1, call this equation 2, multiply equation 1 by x minus 2, equation 2 by x minus 1. Remember, this is what we want to achieve in the end. When we do that, what do we get? We get p of x into x minus 2 equals q of x into x minus 1 into x minus 2 plus 2x minus 4. 2 into x minus 2. X minus 1 into p of x is r of x into x minus 1 into x minus 2 plus x minus 1. I'm going to call this equation 3, equation 4. Remember, there is q of x into x minus 1 into x minus 2, r of x into x minus 1 into x minus 2. If I add these two, x minus 1 into x minus 2 will be there, which I like. And then this remaining part will be there, which also I like. But then that will be x minus 2 into p of x plus x minus 1 into p of x. 2x minus 3 times p of x, which I am not very happy with. Right? But if I subtract one from the other, if I subtract equation 4 minus equation 3, from this I subtract this because this is x minus 1, that is x minus 2. From x minus 1 I subtract x minus 2, I'll get p of x equals r of x minus q of x times x minus 1 into x minus 2 plus x minus 1 minus 2x plus 4 minus x plus 3. Now this is exactly like this. T of x is r of x minus q of x into x minus 1 into x minus 2. This side is p of x, or the remainder is minus x plus 3 or 3 minus x. Brilliant question. Let greatest integer of x denote the greatest integer not exceeding x. That is, if you think about it, of 1.2 is 1, 3.79 is 3, greatest integer of minus 1.83 is minus 2. If it were an integer, greatest integer of 3 is 3. Right, lovely. And I'm going to call this curve bracket of x is x minus greatest integer of x. So curve bracket of 2.79 is 2.79 minus greatest integer of 2.79, which is 0.79. Lovely. So for want of a better word, I'm going to call it the decimal part of x. And so it works beautifully if we're talking about positive x. Negative x, it will not be the decimal part, it will be the remaining. Right? But hey, I need a phrase, so I'm going to call it the decimal part of x. If n is a natural number, then the sum of all values of x satisfying the equation 2 into greatest integer of x, 2 into greatest integer of x equals x plus n times decimal part of x. I don't even know how to approach this question. When n is a natural number, the sum of all values of x satisfying the equation blah 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 is what is that equal to. And what I'm going to do, I have choices. I'm going to play with this a little bit. I know that x is nothing but greatest integer of x plus decimal part of x, the remaining part of x. So what I'm going to do, I'm going to say, hey, this I'm going to write it as greatest integer of x plus greatest integer of x, and then add the decimal part of x equal to x plus n times greatest integer of x plus, n times decimal part of x plus decimal part of x. What am I doing? I'm adding decimal part of x to both sides. Why am I doing that? Because here I can identify an x here and an x here. These two disappear. Or we simply have a situation where we have greatest integer of x equals n plus 1 times decimal part of x. Lovely, brilliant. Now we need to find sum of all values of x satisfying the equation, this equation. For a given n, I don't know how to do this. I'm going to put an n. I'm going to say, hey, n equal to 1. Decimal part of x, greatest integer of x is 2 times decimal part of x. Decimal part of x goes from 0 to 0.99999. So 2 times decimal part of x can go from 0 to little less than 2. Right? So it can go from 0 to 2, but less than 2. It cannot be 2. When will it be 0? When this is 0, then this should also be 0. Then 0 is a solution. Then hey, I don't care about 0 because 0 is a possible solution for this equation. Let's keep that aside. Let's not worry about 0. 0 is always a solution for this equation. Greatest integer of 0 is 0, x is 0, decimal part of 0 is 0. It goes to 0 comfortably. So if you ignore 0, then 2 times decimal part of x is equal to greatest integer of x. The only place this can happen is if I have this going to 1 and that going to 1 as well. Right? Or I could have a scenario where this is 2 into 0.5 equal to 1. When will that happen? When x is 1.5. Greatest integer should be 1. The decimal part should be 1. When x is 1.5 and n is 2. And so then we can say greatest integer of x is 1. Decimal part of x is 0.5. 0.5 into 2 is 1. So when n is 1, we have one solution, x equal to 1.5. I'm going to stop with that. I'm going to say, hey, nice. You set the ball rolling on this. Let's grab on and put n equal to 4. 2 into greatest integer of x equals, sorry, we have simplified this, greatest integer of x equals 5 times decimal part of x. 5 times decimal part of x cannot be 5, that should be less than 5. 0, 1, 2, 3, 4. If we ignored 0, we're only thinking about 1, 2, 3, 4. So this can be 1, this can be 2, this can be 3, this can be 4. Nice, brilliant. So what will be the decimal part of x? This is the greatest integer part of x. This were 1. Then 5 into decimal part of x should be this. That means decimal part of x should be 1 by 5. This is 2. Decimal part of x should be 2 by 5. 3 by 5. 4 by 5. Brilliant. Now we are on to something. Now we don't need to find how many values are there. We don't need to find the different solutions. We want to find the sum of all such possible values of x. And so 1, 1 by 5, 2, 2 by 5, 3, 3 by 5, 4, 4 by 5. Add all of that up. So this is 1 plus 2 plus 3 plus 4, 10 plus 10 by 5. Nice, brilliant. Because it is 1 plus 2 plus 3 plus 4 by 5. 1 plus 2 plus 3 plus 4 is 5. 10 plus 10 by 5 is 12. When n is equal to 4, our answer is equal to 12. Now we have to extrapolate this. And so when n becomes 5, this will become 6. I'll have 1, 2, 3, 4, 5. I'll have 1, 1 by 6, 2, 2 by 6, 3, 3 by 6, 4, 4 by 6, 5, 5 by 6. Now I'm going to solve it for n and not for numbers. N is n. Greatest integer of x equals n plus 1 times decimal part of x. This is 1. This is, I'm just thinking, I'm just pausing to see what it should be. It should be 1 by n plus 1, n plus 1, 2, 2 by n plus 1, 3, 3 by n plus 1, all the way till n. This is n by n plus 1. If I add all of this, n into n plus 1 by 2. So n into n plus 1 by 2. 1 by n plus 1 plus 2 plus 3 plus 3 is n into n plus 1 by 2. Times n plus 1. So this goes away. N by 2 into n plus 1 plus 1. N into n plus 2 by 2. This answer. Absolutely delightful question. It took me a long way to just get the hang of this question. Think about greatest integer of x, decimal part of x, understand that, and think about what solutions are possible if n were 1, then n equal to 3, 4, then n equal to n. Solve it methodically, get to the answer. Probably not a very meaningful question to attack in an exam context, but a fun question to attack just like that. And so I'm doing it just like that, so I'm quite enjoying it. But from an exam point of view, probably a question, look at it and go, very interesting. Thank you very much. I'll come back to it later. A plus b by b plus c equals c plus d by d plus a. Which of the following statements is always true? I'm going to use this. A plus b into d plus a equals c plus d into b plus c. Let's expand this. AD plus BD plus A square plus AB equals CB plus BD plus C square plus CD. Does anything get cancelled? Yes, BD gets cancelled. So AD plus AB plus A square, CB plus C square plus CD. There's some symmetry about A and C. So what I'm going to do, I'm going to take this as AD minus CD plus AB minus CB plus A square minus C square. AD minus CD, A square minus C square, AB minus CB is equal to 0. Or this is D into A minus B plus D into A minus C, plus b into a minus c plus a plus c into a minus c is equal to 0, or a minus c common to d plus b plus a plus c is equal to 0. This tells us that either this is 0 or this is 0, or a minus c is 0, a is equal to c, or a plus b plus c plus d is 0. Either one of them is true, this will hold good. Either a is equal to c or a plus b plus c plus d equal to 0, both work. Answer choice D, D for delta. Log sin x to the base cos x plus log cos x to the base sin x equal to 2. Beautiful question. Log a to the base b is 1 by log b to the base a. So to start with, if I call this as a y, this will become 1 by y. Now y plus 1 by y is greater than or equal to 2 or less than or equal to minus 2. Always it's either greater than or equal to 2 or less than or equal to minus 2. So if y plus 1 by y is equal to 2, there's only one possibility where y equal to 1. You can think of it as a standard rule or AMGM inequality, plug it here. If y plus 1 by y equal to 2, then y has to be 1. Right? So y plus 1 by y by 2 is greater than or equal to square root of y into 1 by y. So y plus 1 by y by 2 is greater than or equal to 1, or y plus 1 by y greater than or equal to 2. Equality holds good when y equal to 1 by y is 1. This tells us quite beautifully that log sin x to the base cos x is 1, which is nothing but log cos x to the base sin x as well. This is 1 plus 1 equal to 2, or quite simply sin x equal to cos x. Now both sin x is equal to cos x, when will it work? It can work bang in between here. All silver teacups. Here only sin is positive, cos is negative. Here cos is positive, sin is negative. Here both are positive, both are negative. And when will they be equal? At 45 degrees. So at 45 degrees it will work. This will not work because sin x and cos x will both be equal in one point here, but both will be negative. Both will be minus 1 by root 2. Here both are plus 1 by root 2. There's no such thing as log of minus 1 by root 2 to the base minus 1 by root 2. Log is not defined for negative numbers or negative bases. So we shouldn't include this. We include only that. There's only one point, which is 45 degrees or pi by 4. So I'm looking for the answer choice pi by 4, which is not present. We have complicated this. So pi by 4 will work. 360 plus pi by 4 will work. 720 plus pi by 4 will work. Or it is 2 pi plus pi by 4, 4 pi plus pi by 4, 6 pi plus pi by 4, 2n pi plus pi by 4 where in an integer. So one angle is 45 degrees, only 45 degrees work. But how do we write it in complicated mathematical trigonometric pi by 4 radians using fraction? There is this. A helicopter flies along the sides of a square field of side 100 kilometers. Okay. 100 kilometers, each is 100. At a speed of the first side is covered at 100 kilometers per hour. For each subsequent square, the speed is increased by 100 kilometers per hour till it covers all the sides. The next 100 is at 200. This 100 is at 300. This 100 is at 400. What is the average speed that is taken? Average speed is total distance by total time. Total distance is 400 kilometers. Total time, let's find total time. 100 kilometers per hour, 100 kilometers and 100 kilometers per hour. 100 by 100 plus 100 by 200 plus 100 by 300 plus 100 by 400. 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, that is the total time taken. Total distance is 400. 400 divided by this is our answer. So the LCM is 12. 12 by 12 plus 6 by 12 plus 4 by 12 plus 3 by 12. 18, 22, 25. 25 by 12 hours. Total distance traveled is 400. 400 kilometers at traveled in 25 by 12 hours. Average speed will be 400 into 12 by 25. So 16 into 12, 192 kilometers per hour. Average speed is always total distance by total time. Find total distance, find total time, simplify it, you're done. In a chess tournament, there are 5 contestants. Each player plays against all the others exactly once. No game results in a draw. The winner in a game gets 1 point, loser gets 0 points. Which of the following sequences cannot represent the scores of the 5 people? In all of these questions, I love looking at the total number of games played. Total number of games played is 5C2, which is 10. In each game, one person gets 1, another person gets 0. So total points per game is 1. Or total points equal to 10. The maximum points any one player can get is 4. Minimum points is 0. One player can win all 4 matches. One can lose all 4 matches. You win all 4, you get 4. You lose all 4, you get 0. All numbers should be integers because there are no draws. Total number of points should be 10. Nobody should have got more than 4. Nobody could have got less than 0. Let's look at this. 3, 2, 2, 2, 1 adding up to 10. 3, 2, 2, 2, 1. Seems possible. 4, 4, 1, 1. Oops, this is wrong. A guy who wins 4 points has to win all 4 games. There cannot be another person who wins all 4 games. What would have happened to the game between these 2 fellows? 2 fellows cannot finish at 4 points each. That's not possible. Because then both of them are winning all their matches. How can 2 people win all their matches? That's not possible. There is a match between the 2 of them. That either one could have won, not both. So this is straight away out. 2, 2, 2, 2, 2, very much possible. All equal, very much possible. 3, 3, 2, 1, 1, 6, 8, 9, 10, possible. Maximum is 4, that's not violated. All of these are feasible, this one is not. 2 people could not have won all their round robin matches. It's not possible. Choice 2. So none of these conditions really played out. But the logic that 2 people could not have won all their matches, that plays out. A rabbit sitting at the base of a staircase which has 10 steps. It proceeds to the top of the staircase by either climbing 1 step at a time or 2 steps at a time. The number of ways it can reach the top. So it goes either 1 at a time or 2 at a time. So it could do 1, 1, 1, 2, 1, 2, so adding up to 3, 5, 6, 8, 10. Or it could do all ones or all twos. And so we need to find how many different ways are there for doing it. All of these questions start from one extreme, go to the other. Say all ones, other extreme all twos. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. All 1 steps, all 2 steps. Then next combination could be 4 twos and 2 ones. Next could be 3 twos adding up to 6, 4 ones. Next could be 2 twos adding up to 4, 1, 2, 3, 4, 5, 6, 6 ones. Then could be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 8 ones. These are the combinations in which 1 step and 2 steps can be combined to add up to 10 steps. All good. We're not done with this. We have to think about the fact that, hey, this 2 could be anywhere. These 2 twos could be mixed up. And all 10 steps are 1, that can be done in only one way. All 5 steps are 2, that can be done in only one way. In how many ways can this be done? 8 ones and a 2. 2 can be anywhere here. So this is 9 factorial by 8 factorial, 9 ways. 2, 2, 1, 1, 1, 1, 1, rearrange. 8 factorial by 6 factorial into 2 factorial. Or 8C2, from 8 slots, select 2 for this 8 into 7 by 1 into 2. This is 1, 2, 3, 4, 5, 6, 7, 7C3, 7 into 6 into 5 by 1 into 2 into 3. This is 6C4 or 6C2, 6 into 5 by 1 into 2. Add all of this up. This is 1, this is 9, 8 into 7 by 1 into 2, 4 into 7, 28, 2 into 3 is 6, that goes away, 35, 6 into 5 by 2, 3 into 5, 15, 1, 10, 18, 23, 28, 29, 9, 2 carried over, 4, 7, 8, 89. Get these categories in, put them in, then worry about how they can be rearranged and mix up. Get through. Which of the following straight lines are both tangent to the circle? Given a circle, I have a circle, I want to find center and radius. How do I like that? Fine, so let's do this. This is x square minus 6x plus 9, y square plus 4y plus 4 equals 9 plus 4 plus 12. What am I doing here? I'm completing the square. X square minus 6x plus 9 is a nice square. I have 9 here, I'll put 9 there. Y square plus 4y plus 4 is a nice square. I have 4 here, I'll put 4 there. I take the minus 12, put it that side, it becomes plus 12. Or this is x minus 3 the whole square plus y plus 2 the whole square is 25, which is 5 square. Or think about it, the center is 3 comma minus 2, radius is 5. Square root of 3 square plus 2 square is square root of 13, 3 point something, so this goes out. A circle like this. Center is 3 comma minus 2, radius is 5. Now, which of the following straight lines are both tangent to the circle? Two straight lines. And so 4x plus 3y plus 19 equal to 0, 4x plus 3y minus 31 equal to 0, plus 19 plus 31, minus 19, minus 31, minus 19, plus 31. All combinations of that. 4x plus 3y is a line. So it's a line like this or a line like this. How do I find this? Suppose hypothetically I assume a line, a tangent line to be a line like this. Then this tangent is perpendicular to radius. So from center of the circle, if I draw a line to the point of tangency, that should be perpendicular to that, and we can find the perpendicular distance. What am I going to do? I'm going to take this 4x plus 3y plus 19 equal to 0 and find the distance from 3 comma minus 2. So 4x plus 3y plus 19 equal to 0 from 3 comma minus 2. What is this perpendicular distance? 4 into 3 plus 3 into minus 2 plus 19 by square root of 4 square plus 3 square under modulus. 4 into 3 is 12 minus 6 plus 19, 12 minus 6 plus 19 divided by 5. 6 plus 19 is 25, 25 by 5 is 5. Yay, brilliant. So, hey, 4x plus 3y plus 19 is definitely a tangent. 4x plus 3y plus 19 is definitely a tangent. So, this is in, because distance from the center, perpendicular distance from the center of the circle to this line is equal to the radius. So, from here, if I draw a line perpendicular to this line, that distance happens to be 5. So, the point of intersection of the perpendicular lies on the circle, or the radius is perpendicular to the tangent at the point of tangency. This works. So, it is one of these two. My gut feel is it has to be this, because 4x plus 3y plus 19 equal to 0 has to be a line this side. So 31 should be minus on that side. Let's check it out. This works. So I'm going to check this first and then come to this. 4x plus 3y minus 31 equal to 0. I'm comparing from 3 comma minus 2. This perpendicular distance is what I want to calculate. 4 into 3 minus plus 3 into minus 2 minus 31 by square root of 3 square plus 4 square under modulus. 12 minus 6 is 6, 6 minus 31 is minus 25 by 5 under modulus equal to 5. Very first one, it worked. What you're doing here, from center of the circle, finding the distance to this line, perpendicular distance. From center of a circle, perpendicular distance to a straight line, if it is equal to radius, then said straight line has to be a tangent to the circle. So plugging that in and then simplifying it through choice A. A person standing at the center of an open ground first walks 32 meters towards east, takes a right turn and walks 16 meters, 32, 16, takes another right turn and walks 8 meters, and so on. So this will be after 8 will be, oops, say 4, and then it'll swirl in. Nice, brilliant. How far will the person be from the original starting point after an infinite number of such walks? And so think about this as two sequences. This 32, this 8, this number, all horizontals, and then all verticals. Horizontal will be 32 eastwards, followed by 8 westwards. Right turn, 4, 2 this way, and then 1.5 this way. The vertical ones will be 16 downwards, 8, 4 upwards, 1 downwards, 1/4 upwards, and so on. We're done, we're through. We add all of these up, we add all of this up, and then we can simplify. How do I add all of this up? This is a geometric progression with the common ratio of 1/4, not just 1/4, minus 1/4. 32 this way, 8 this way. And so this, the horizontal sequence eastwards, if you think about it, it's plus 32, minus 8, plus 2, minus r, and so on. So a by 1 minus r, total eastward distance is 32 by 1 minus 1/4. Vertical distance is 16 minus 4 plus 1 minus 1/4, and so on. Total is 16 by 1 minus 1/4. This will be half of that. 32 by 5/4. This is 32 into 4/5. This is 16 into 4/5. What is the total distance? 32 into 4/5. 16 into 4/5. This square root of this square plus that square. I can take out the 16 into 4/5 outside. The square root of 1 square plus 2 square. 16 into 4/5, 32 into 4/5, 1:2, square root of 1 square plus 2 square into 16 into 4/5. 16 into 4 is 64/5 times root 5. 64 root 5/5. Hopefully that is there in our choices. It is 64 by root 5. 64 root 5/5 is 64 by root 5. That's how. X square plus y square minus 2x minus 4y plus 5 equal to 0 represents, I look at it and go circle, but hey, we'll pause. We'll say, hey, this is x square minus 2x plus 1, y square minus 4y plus 4 equals minus 5 plus 1 plus 4. What am I doing? I'm just completing the square. X square minus 2x plus 1 is a nice square. Y square minus 4y plus 4 is a nice square. I'm adding 1, I'm adding 4, I'll add 1 and 4 that side. Plus 5 goes that side, goes to minus 5. Or this is x minus 1 the whole square plus y minus 2 the whole square is equal to 0. There's a beautiful circle with center 1, 2 and radius 0. Or it's a point. Beautiful question. Look at this question and go, what a freebie. Nice, I can just simplify it and then mark the answer as a circle. Without even simplifying, I can mark the choice as a circle. No, you simplify it and you realize the circle with 0 radius, which is nothing but a point. So wonderful trap. If you're in a hurry, you can just read this, scan this, mark circle, earn yourself negative marks. Be a little careful. Cos alpha plus cos beta equal to 1, then the maximum value of sin alpha minus sin beta. Very nice. So cos alpha plus cos beta is equal to 1. Let's say sin alpha minus sin beta is equal to n. I know sin square alpha plus cos square alpha is 1. Sin square beta plus cos square beta is 1. I know I can deal with the squares, so I'll square this. So cos square alpha plus cos square beta plus 2 cos alpha cos beta equal to 1. Sin square alpha plus sin square beta plus 2 sin alpha sin beta equal to n square. Very interesting, a lot of fun. So what do? We add these two. Sin square alpha plus cos square alpha, 1. Cos square beta plus sin square beta, 1. Plus 2 times cos alpha cos beta plus sin alpha sin beta equal to 1 plus n square. Nice. 2 times cos alpha cos beta plus sin alpha sin beta. Cos alpha cos beta plus sin alpha sin beta is cos of alpha minus beta, which means we can knock off this one. 1 plus 2 times cos of alpha minus beta is equal to n square. 2 times cos of alpha minus beta can go from minus 1 to plus 1, and it cannot really go to minus 1 because that n square sitting here, 1 minus 2 minus 1, that's not possible. Least value this can take is 0. The highest value this can take is 2. The least value this can take is minus 1, or n square minimum 0. I'm not worried about n square minimum, but the question is find the maximum value of sin alpha minus sin beta. What is the maximum value it can take? N square maximum is 3. When this goes to 1, 2 times 1 is 2, 1 plus 2 is 3. Or n maximum, 3. Sin alpha minus sin beta, maximum value is root 3. When does that happen? That happens when cos of alpha minus beta is 1. Let me simplify like that. Let p be a positive integer such that the unit digit of p cube is 4. What are the possible unit digit of p plus 3 whole cube? P cube unit digit is 4. That means p is even. So p unit digit could be 0, 2, 4, 6, 8. P cube, if p had unit digit 0, p cube would have unit digit 0. It had 2, 2, 4, 8, this will be 8. 4, 4, 16, 64, 4, 6, 6, 36, 2, 16, 6, 8, 64, 512, 2. So if I know that unit digit of p cube is 4, then, hey, very nice, very interesting. Unit digit of p cube is 4. That means p does not end in 0, p does not end in 2, p does not end in 6, p does not end in 8. P ends with 4. Unit digit of p is 4. What are the possible unit digit of p plus 3 whole cube? P plus 3 will end in 7. 7 cube will end in 7, 49, 343. It ends in 3. Only possible value is 3 and true. Freebie, absolute freebie. We're basically saying take this mark. The probability that a randomly chosen positive divisor of 10 power 2023 is an integer multiple of 10 power 2021. So 10 power 2023 is 2 power 2023 into 5 power 2023. How many factors does this number have? 2024 into 2024. 2024 square. It should be our denominator. How do I get that? Any factor of this number of the form 2 power a into 5 power b. A can take all values from 0 to 2023. B can take all values from 0 to 2023. 2024 values each. That's why we have that many factors. Nice, brilliant. Now, probability that a randomly chosen positive integer of 10 power 2023 is an integer multiple of 10 power 2001. Second condition. Denominator is this 2024 whole square. That many factors are there for this number. What are the numerator? Under what conditions will this factor of this number be a multiple of 10 power 2021, 10 power 2001? So 2 power a into 5 power b should satisfy two conditions. Factor of 10 power 2023 and multiple of 10 power 21. Sorry, 10 power 2001, not 21. Sorry about that. Brilliant. So this number should be a multiple of this. That means it should contain 2 power 2001 and 5 power 2001. Or what values can A take? A can go from 2001 to 2023. What values can B take? B can again go from 2001 to 2023. Or A can take 23 values, B can take 23 values. How many possible numbers are there? 23 into 23 combination. Or the probability that we are looking for is within this many numbers. What are the chances our number is within this subset? Our probability is 23 into 23 by 2024 into 2024. 23 square by 2024 square. Nice and simple. Seems like a very intimidatingly tough question. It is not.